Hello students, welcome to the fifth session of our fourth module in RAC. Today we will be studying about cooling towers. So you will be wondering what actually is cooling tower. You have never heard of that word, at least in my class. Some of you might have heard it somewhere else, but not in my class because I have never mentioned this. Actually, what is cooling tower? Cooling tower is so you know that there are four basic components in a refrigeration system, right? Four basic components. So if this is compressor, then this is condenser, evaporator, expansion valve, right? So students, you have learned that this the hot gas coming out of compressor will be of high pressure, and it will be cooled here. It will be condensed here in condenser, right? So for condensing, you need some medium. It can be either air or water. In many of the cases, water is acting as a cooling medium. So what actually condenser is a heat exchanger. You have already studied in the previous classes different types of condensers and all. So if this is a condenser, so this hot gas is coming from compressor, and condensed fluid is coming out, going out of the condenser. So in order to cool this medium, you cool this gas, you need some other medium. It can be either air or water. If this is water, some cold water should come into the condenser, and when it leaves the condenser, it will be some warm water, right? Warm water. So this water should again be recycled, right? So we will be having some shortage in limited. The water will be available in limited quantity only. So it won't be easy to produce to inject more water, new water to that condenser. It will be easier if you recycle this water. So this warm water should again be cooled, and that cooled water should again be injected into this condenser, right? So it should undergo a cycle, അല്ലേ? അതായത് നമ്മൾ ഈ കോൾഡ് വാട്ടർ ഇൻലെറ്റ് ചെയ്യുന്നത് ഇവിടുന്ന് ഹീറ്റ് ട്രാൻസ്ഫർ നടന്ന് വാം വാട്ടറായി പുറത്തേക്ക് പോയി. ആ വാം വാട്ടർ നമുക്ക് വീണ്ടും തണുപ്പിച്ചാൽ വീണ്ടും കണ്ടൻസറിലേക്ക് ആഡ് ചെയ്യാൻ പറ്റുമല്ലോ. അങ്ങനെ ആഡ് ചെയ്താൽ മാത്രമേ നമുക്ക് ലിമിറ്റഡ് ക്വാണ്ടിറ്റി വാട്ടർ വെച്ചിട്ട് നമുക്ക് വർക്ക് ചെയ്യാൻ പറ്റൂ. അല്ലെങ്കിൽ നിങ്ങൾ പുതിയ വാട്ടർ കണ്ടിന്യൂസ് ആയിട്ട് പമ്പ് ചെയ്ത് കൊടുക്കേണ്ടി വരും. ഓക്കെ, സോ ഇൻ ഓർഡർ ടു അവോയ്ഡ് ദി ഇൻഡക്ഷൻ ഓഫ് continuous water into this condenser, it will be easier if you റീസൈക്കിൾ ദിസ് വാട്ടർ, അല്ലേ? റീസൈക്കിൾ ദിസ് വാട്ടർ. അപ്പോൾ ഈ വാട്ടർ റീസൈക്കിൾ ചെയ്യണമെങ്കിൽ എന്ത് ചെയ്യണം? അതിനെ തണുപ്പിക്കണം. ആ തണുപ്പിക്കാൻ വേണ്ടി നമ്മൾ യൂസ് ചെയ്യുന്ന കോമ്പോണൻ്റാണ് ഇത് കൂളിംഗ് ടവർ. കൂളിംഗ് ടവർ എന്ന് വെച്ചാൽ ഈ വാട്ടർ നമ്മൾ എയർ വെച്ചിട്ട് തണുപ്പിക്കുക. കൂളിംഗ് ടവർ, ഓക്കെ, അതിനാണ് കൂളിംഗ് ടവർ യൂസ് ചെയ്യുന്നത്. ഇനി നോക്കാം, കൂളിംഗ് ടവറിൻ്റെ ഒരു ബേസിക് ഫിഗറാണിത്. അപ്പോൾ കൂളിംഗ് ടവർ എന്താണെന്ന് വെച്ചാൽ ദേ ആർ എ സ്പെഷ്യൽ ടൈപ്പ് ഓഫ് ഹീറ്റ് എക്സ്ചേഞ്ചർ. Special type of heat exchangers that allow water and air to come in contact with each other. For what? For lowering the temperature of water. Lowering water temperature. Okay, so cooling tower acts as a device or heat exchanger that allows water and air to come in contact, so that the temperature of the water can be lowered, so that it can be again fed into condenser. Okay, so during the cooling tower working process, what is actually happening is that some small volumes of water evaporate. Okay, water will be evaporating when it comes in contact with air. And what happens while evaporation takes place? Water will absorb heat from that chunk of that amount of water, the water behind that the surface level. Okay, from uh, the, the 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 water will absorb heat from the water itself, and it will get evaporated, so that the water behind the left behind the evaporated water will be cooled down. Okay, so during the cooling tower working process, small volumes of water evaporate, lowering the temperature of that water that is being circulated through cooling water. Okay, so have a look at this figure. Hot water is actually this hot water from condenser is fed into this cooling tower. Okay, so that water is pumped through pipes. Actually, it will be pumped through pipes directly into this cooling tower. So cooling tower has got numerous nozzles. You can see spray nozzles which are connected to some distribution system. When it comes out through the nozzle, the water will be in the spray format, right? So these cooling tower nozzles are used to spray the water into some film media. This media is known as film material or film media. So this film media is used to slow down and expose the maximum amount of water surface area possible for the what possible for best contact with the air, dry air. So this when before after leaving from this spray nozzles, the water will be having very high velocity. So in order to bring this water to a lower velocity, so a fill media is used, so that water will be slowing down. If it slow down means it will have a better contact with the air that is coming through this area. So air is coming through this area. So in order to suck this air from this area, a fan is used here. Okay, this fan will create a draught, or it will suck air from the lower portion of the cooling tower, so that this air and water will come to contact. And what happens? The water is exposed to air as it flows through the cooling tower. Okay. So when the air and water come together, a small volume of water evaporates. A small volume of water evaporates. So here, so in this region, the water will start to evaporate, creating an action of cooling, right? Create an only small portion of water evaporates. The remaining portion of water will this evaporated water uh, will exit from the cooling tower along with the air. So what happens to air? The dry air will become moist air when it exits from the cooling tower. It will become moist means its water vapor content will increase, because the air is evaporated, the water is evaporated in this region. So there will be some remaining water. Only small portion of water will evaporate. The remaining water will be collected in this collection basin. Okay, so what will be the temperature of the remaining water? The remaining water will have a lower temperature. Why? Because the small amount of water evaporated in this portion will absorb heat from the remaining portion of water, right? So the water will have a lower temperature when it is collected in the basin, and this cold water will move out to condenser. So the refrigeration cycle can continue working. So this is the basic working of a cooling tower. Okay, there are numerous types of cooling towers. You can learn about different types of cooling types of cooling tower. So different types of cooling tower. First one is a cross flow type. So different types of heat exchanger based on the direction of flow. So basically, cooling tower can be assumed as a heat exchanger. So depending upon the flow of air and water, the direction of flow of air and water, the cooling tower can be classified into different types. So here you can see that water water. So this water is flowing vertically downwards. Hot water is flowing vertically downwards. There is a fan here. This fan will suck air in this direction. So the air direction is perpendicular to the flow of water. Actually here water is flowing solely based on the gravity. Hot water flows via gravity, and distribution basins or any kind of sprays are not present here. No spray mechanism. Water actually flows based on gravity only, but the direction of water and air is perpendicular. That is why the name cross flow. This is a cross flow cooling tower. So the water vertically flows through the fill media. This is a fill media, while the air horizontally flows. Air horizontally flows across the falling water. That's why they call it as cross flow. Okay, because of the crossing of flowing, the air doesn't need to pass through the distribution systems. Okay, uh, the hot water flow takes place via gravity. Okay, generally a larger plan area but lower height. That is the requirement of this type of. So it requires large area but a small height. The height can be very low. So situations where we cannot afford much height, in those situations cross flow cooling towers will be used. So another type of second type is counterflow. Counterflow. So this is basically the same type of flow that we have here. In the introduction part we have discussed a counterflow heat exchange cooling tower, because in counterflow there will be a distribution system, a nozzle. Water will be flowing not by gravity but by pumping spraying mechanisms, and air will be passing or moving vertically upward. So the flow will be in counter direction. Water will be downwards and air will be upwards. So that is why the name counterflow cooling tower. So the air vertically flows upwards counter to the water flow in the fill media. Okay. As a substitute, these towers use pressurized spray system. Okay. So since it is not flowing based on gravity, these towers are using pressurized spray system, usually pipe type. Okay. So these are commonly used in air conditioning and refrigeration system. In our domestic, some not domestic, in domestic application, these cooling towers may not be actually required. It is basically used in industrial purpose only, HVAC applications. HVAC applications, that is where chillers and other larger equipments come into play. Okay, so next will be, third one will be hyperbolic. So you can see here the shape is somewhat hyperbolic. So hyperbolic towers are structurally strong and use a minimum of materials. Okay, these are used for handling larger projects like nuclear or some coal-fired power plants. So these are used in coal power plants. So hyperbolic towers. So this is known as hyperbolic tower. Operate through a chimney or stack effect. So you know that chimney effect. When the air outside the cooling tower is cooler than the air inside the tower. So air outside the tower. So here air temperature is lower. Okay. Here air temperature, comparatively air inside the tower will be higher air temperature. Okay. So what happens? The air outside forces the humid air outside forces the humid inside air to travel upwards. Okay, this air will force, air will push this inside air, inside humid warm air to travel upwards. Okay, that is how this chimney, that is what chimney effect means. Okay, so there will be a motion, the continuous motion of air through this hyperbolic air tower, cooling tower. So there will be a continuous motion of air. Okay. So some fill material is placed in this lower portion of the tower. Water will be sprayed over this fill material, and the water is cooled by this natural draft. Actually here natural draft is taking place. Okay, natural draft means due to this density difference, since the air outside the cooling tower is having a lower temperature and air inside the cooling tower is having a higher temperature, naturally the air outside the cooling tower will push this air inside the cooling tower to move outwards, upwards, and it will exit the cooling tower. So while that movement, what happens? While that movement, the air will be this water will be sprayed over this air, so that evaporation takes place and it will get cooled, and this cold water is fed into the condenser. Okay, actually this type of structure requires large space due to height and width. Okay, and it will be having some very high initial cost, but it is very cheap to operate. So this self-supported structure can withstand a wind velocity of almost 150 km per hour and all. So this is actually a very large structure used in nuclear or coal powered fired power plants. Okay. Now we will learn about a natural drought. Another classification. This is based on structure. Another classification on the basis of methods of airflow. Methods of airflow. Classification based on methods of airflow. First one is natural drought cooling system. Natural natural drought cooling tower. Okay. Natural drought cooling tower. So students, we have already discussed the natural drought. Students, natural drought cooling tower is the same that we have studied in the hyperbolic. So this hyperbolic cooling tower is also a natural drought cooling tower, because here you can see that there is no fan or mechanical device for airflow to create an airflow. So it actually works on the chimney effect. So what is this chimney effect? So by enclosing some heated air or a higher temperature air in this chimney, it will create a pressure difference between this heated air and surrounding air, which is cooler than this inside air. Because of this pressure difference, air enters to the cooling tower, and air movement depends on this induction force. Okay, so that is what a natural drought cooling system. Okay, natural drought cooling system, it utilizes the principle of buoyancy to achieve this desired effect. So fluid movement is parallel. Here it is counter flow, right? It's counter flow. It can be either it can be parallel or counter or cross flow, any flow, but it will be natural drought cooling tower only when it works based on this chimney effect. And it may request a large space for installation. Okay, so there are various pros and cons for this natural road system. You can read it in your textbook. While reading will be very useful. Okay, so now second type is mechanical or forced road system. Forced road system or mechanical drought system. So in this type of cooling tower, a fan is used. A fan is used to circulate the air. Here, fan is used to circulate the air. So that is why the name forced rod. Okay, to circulate the air. So that is the type of cooling system that we have learned in the introduction or the initial. So actually this can be considered as a mechanical rod or forced rod cooling tower. Okay, because we are using a fan here. So there is a fan here. Fan will induce the induce the air towards this cooling tower, so that air flows through the cooling tower to up to the upper portion. Okay, so that is forced rod system. Okay, actually there are different two types of forced rod system. Induced type, induced rod cooling tower and forced rod cooling tower. Two types: induced rod cooling tower and forced rod cooling tower. So basically both are known as forced rod or mechanical rod. When specifically we can classify it as two types: induced rod cooling system and forced rod cooling system. So this is an induced cooling tower. So what is the difference here? You can see that if a fan is mounted on the top of the tower, so you can see that fan is mounted on the top of this tower. So such cooling tower is known as induced rod cooling tower, because it pulls the air. It pulls the air throughout the tower. So it pulls the air from the lower portion to the upper portion. Okay, so the air will pass all over the tower. Okay, so the water is sprayed and broken into droplet and is cooled by this. The water flows downward, the air flows upward, and naturally evaporation takes place and water will get cool and it is collected in the collection basin. Okay, so the main point you have to note that in induced cooling tower, the water is placed on the top and water pulls the not water sorry, the fan is placed on the top. The fan will pulls the fan pulls the air from the lower portion to the upper portion. So the exit velocity of air is quite high when compared to the entry velocity. Okay. Now we will move to the forced rod cooling tower. Here you can see that fan is placed here. Okay, fan is placed here. It contains some horizontal shaft for the fan situated at this intake. This is situated at the air intake, and it is placed at the bottom of the tower. Okay, so actually fan is pushing the air, not pulling. In induced rod cooling tower, fan is pulling, but in forced rod cooling tower, fan is pushing the air. Okay, so the hot water coming from the condenser enters the unit here, and it gets sprayed through the nozzle. Water droplets moves towards downwards. Okay, hence here the entry velocity of the air is quite high in comparison to the exit velocity. Actually here the air velocity will be very high, but when it reaches the exit area it will be lower. But in the induced cooling tower, the exit velocity high as compared to the entry velocity. Okay, so generally the forced the cooling mechanical rod cooling system can be classified into two based on the position of the fan. If it is in the top, if it is mounted on the top of the system, it is induced cooling tower because air is being pulled here. But in case of forced rod cooling tower, fan is placed at the bottom of the cooling tower. The air is pushing here. Okay, air is getting pushed here. Okay, so that is the difference. So that's all about cooling towers. So you have studied cooling towers, its classification. So with this we can conclude this session for cooling towers. In the next session we will be learning a small portion called leak detection. Okay, leak detection in refrigeration system. Leak detection and charging. Charging means adding refrigerant to the system. So we will discuss about leak detection, charging, and some control method, control system or control devices used in refrigeration system in order to enhance the performance of the refrigeration system. All this will be discussed in the next session, and with that section we will conclude the fourth module. So for the time being, I am stopping this particular section. Thank you.